Welcome everyone. This is Dr. Giuma, Department of Mathematics from Satyabama Institute of Science and Technology. Today we are going to see a topic complex variable. Okay, let us see the complex variable definition or the introduction of a complex variable. The general form of the complex number or a variable, it is denoted by z is equal to x plus iy, where x and y are real values. X is called the real part of z and y is also called a imaginary part of z. Now the conjugate of a complex number is denoted by z bar is equal to x minus iy. Now let us add these two, z plus z bar, which is equal to 2x, which implies x is equal to 1 by 2 of z plus z bar. Then subtraction of z minus z bar. Let us subtract this, we will get 2iy, which is equal to y, which is equal to 1 by 2i of z minus z bar. Now the multiplication of z into z bar, which is equal to x plus iy into x minus iy, which gives x square plus y square. Then if we take the modulus of any complex number, that is modulus of z, which is equal to, we will get root of real square plus y, imaginary real part square plus imaginary part square. In other words, which is equal to root of x square plus y square. Now the polar form, now what we have seen as a Cartesian form of a complex number or a complex variable. Now what we are going to see, the polar form of a complex variable. So z is equal to, what we know till now, we know z is equal to x plus iy. Now which is equal to r into cos theta plus I sin theta, which is equal to r e power I theta. We know that e power I theta is equal to cos theta plus I sin theta. Here x is equal to r cos theta and the imaginary part y is equal to r sin theta. By adding and squaring, we get x square plus y square is equal to r square. This implies an equation of a circle centered at the origin with the radius r. Now, we will see the Euler's formula. We know that e power I n theta is equal to cos n theta plus I sin n theta. By De Moivre's theorem, cos theta plus I sin theta the whole power n, which is equal to cos n theta plus I sin n theta. E power minus I n theta is equal to cos n theta minus I sin n theta. The functions of a complex variable. Z is equal to x plus iy and w is equal to, or it is denoted by the letter omega. Here it is denoted by the letter omega. Usually the complex variable is denoted by w is equal to u plus iv. And if z and omega are two complex numbers, and if for each value of z in a complex plane then corresponds to more values of a, then omega is said to be a function of z. We can write it in a form w is equal to, or omega is equal to f of z, which is equal to u plus iv. That is, u is equal to x comma y plus iv of x comma y. U is a variable which in terms of x and y, and similarly v is a function of variable having a variable x and y. Here u and v are real functions and of the real variables x and y. For example, f of z is equal to z square. We know that z is equal to x plus iy. By squaring that, we will get the real part as x square minus y square and the imaginary part as 2xy. First, the definition, continuous of a complex variable. A function f of z is said to be continuous at the point z is equal to z0 if limit z tends to z0, f of z is equal to f of z. If f of z is continuous in any region or of the z plane, then it is continuous at every point of that region. Derivatives of f of z, very important definition. Using this definition only, we are going to derive Cauchy Riemann equations, the necessary conditions of Cauchy Riemann equation. Let omega is equal to f of z be a single valued function of the variables z. Then the derivative of f of z is defined as dw or d omega divided by dz is equal to f dash of z. The derivative of f of z, which is equal to limit delta z tends to 0 f of z plus delta z minus f of z the whole divided by delta z if limit exists. The condition is if limit exists. Then the partial differentiation of u is dou u divided by dou x, which is equal to, that is the partial derivative of u is equal to limit delta x tends to 0 u of x plus delta x comma y minus u of x comma y divided by delta z. Then dou u divided by dou y is equal to limit delta y tends to 0 u of x comma y plus delta y minus u of x comma y divided by delta y. The very important definition here goes analytic function. A single valued function f of z, it possesses a unique derivative with respect to z at all points of a region R is called a analytic function. It is also called regular function or holomorphic function. Analytic function is otherwise called regular function or holomorphic function. Now, singular point, we'll see a definition of a singular point. A point at which an analytic function f of z is possesses a derivative is called a singular point of the function or singularity of f of z. Now we will see the necessary and the sufficient condition for the derivative of f of z. Necessary and the sufficient condition. Then all these partial derivatives should exist, that is dou u divided by dou x comma dou u divided by dou y comma dou v divided by dou x comma dou v divided by dou y are continuous functions of x and y in the region R. Then ux is equal to vy. In other words, dou u divided by dou x is equal to dou v divided by dou y, and dou u divided by dou y is equal to minus dou v divided by dou x. This equation is called a CR equation. Now, we will see the necessary condition for a Cauchy Riemann equation. Let us assume that f of z is equal to u plus iv is analytic. We assume that f of z is analytic in the region R and in the plane. Then f of z, we know that we have seen the definition of a derivative. F dash of z is equal to limit delta z tends to 0 f of z plus delta z minus f of z the whole divided by delta z. We already know what is z is equal to. Z is equal to x plus iy. Then if we multiply by delta, delta z is equal to delta x plus I delta y. Delta z approaches to 0 along the path in the region R. Now we know that f dash of z is equal to, we know what is delta z is equal to. Delta z is delta x tends to 0, delta y tends to 0. This is the real part tends to 0 and the imaginary part it tends to 0. U of x plus delta x comma y plus delta y plus I into, just we are substituting what is z plus delta z, u of x plus delta x comma y plus delta y plus iv of x plus delta x comma y plus delta y minus u of x comma y plus I into v of x comma y whole divided by delta x plus I delta y. The above equation, this equation. Now let us consider delta y tends to 0 in this equation 1. We will substitute delta y is equal to 0 in the equation 1. If I substitute delta y tends to 0, what will happen? Only we will get delta x tends to 0, u of x plus delta x comma y plus I into v of x plus delta x comma y minus u of x comma y plus iv of x comma y the whole divided by delta x. Now, if we simplify this real and imaginary part, we have taken real part separately and imaginary part separately, we will get limit delta x tends to 0, u of x plus delta x comma y minus u of x comma y divided by delta x plus I into limit delta x tends to 0, v of x plus delta x comma y minus v of x comma y whole divided by delta x. This is nothing but, the first part is nothing but the partial derivative of u, and the second part is nothing but the partial derivative of v. So it is dou u divided by dou x plus I into dou v divided by dou x. Now what we have got, f dash of z is equal to dou u divided by dou x plus I into dou v divided by dou x, equating the real part and the imaginary part. So similarly, we have to substitute delta y tends to 0. First we have substituted delta y tends to 0 and we have to substitute delta x tends to 0. We will get two equations, that is dou u divided by dou x which is equal to dou v divided by dou y, and the second equation will be dou u divided by dou y is equal to minus dou v divided by dou x. This is nothing but our CR equations, that is Cauchy Riemann equation. So we will write this also. We can write this equation in a simple way, that ux is equal to vy and uy is equal to minus vx. This equation is called a CR equation, Cauchy Riemann equation. Using this equation, we can check the given function is analytic or not. Now we are going to see function which is analytic or not using this condition, that is dou u divided by dou x is equal to dou v divided by dou y and dou u divided by dou y is equal to minus dou v divided by dou x. Now to find the derivative, f of z is equal to u plus iv, we all know that. To find the derivative, f dash of z is equal to dou u divided by dou x plus I into dou v divided by dou x. So we will recall some formulas. So we know that sine of ix is equal to, converting this into a hyperbolic trigonometric function, will get I into sine hx. Cos of ix is equal to cos hx. We know that sine 0 is equal to 0 and cos 0 is equal to 1. Sine h of 0 is equal to 0 and cos h of 0 is equal to 1. The derivative of sin x is equal to cos x. The derivative of cos x is equal to minus sin x. Sin hx is equal to cos hx and the derivative of cos hx is equal to sin hx. Now we will check the analyticity of a function. The given function f of z is equal to z square. Now what we will do, we will know what is z is equal to. What is z is equal to is x square, x plus iy. Now x substituting z is equal to x plus iy. So we will get x plus iy the whole square. Now squaring it using a plus b the whole square, we will get x square minus y square plus 2i xy. Comparing the real and imaginary part. The comparing of real and imaginary part will get u in the left hand side, f of z is equal to u plus iv. Here the real part is equal to u, which is equal to x square minus y square. Similarly, imaginary part is v is equal to 2xy. Now partial differentiation with respect to x, which is equal to 2x. Partial differentiation with respect to y is equal to minus 2y. Similarly, that side, dou v divided by dou x, which is equal to 2y. Dou v divided by dou y is equal to 2x. Now we have to check the condition of CR. So what is CR equation? Dou u divided by dou x is equal to dou v divided by dou y. So dou v divided by dou y is equal to minus dou u divided by dou x. Both the values are same. So CR equations are satisfied. Hence the given function f of z is equal to z square is a analytic function. Now let us find the one more analyticity for a function f of z is equal to e power z for an exponential function. Now f of z is equal to e power z. E power z can be written in a form e power x plus iy because z is equal to x plus iy. Now e power x plus e power iy. When the bases are same, we can add the powers. Using that formula, we are splitting as e power x into e power iy. We know that e power I theta is equal to cos theta plus I sin theta. So, e power iy is equal to cos y plus I sin y. Multiplying this e power x inside, we will get e power x cos y plus I into e power x sin y. Comparing the real part and the imaginary part in this equation, we will get u is equal to e power x cos y and v is equal to e power x sin y. Finding the partial differentiation with respect to x, dou u divided by dou x is equal to e power x cos y. Similarly, partial differentiation with respect to y is equal to minus e power x sin y. On this side, dou v divided by dou x is equal to e power x sin y, dou v divided by dou y is equal to e power x cos y. Now, say checking the CR equations, it is satisfying the CR equation, that is ux is equal to vy and uy is equal to minus vx. So, hence this function f of z is equal to e power z is also an analytic function. Now, f of z is equal to cos z, a trigonometric function. Z is equal to cos of x plus iy. Multiplying this inside is not possible because cos of an complex number. We have to split this using a cos a plus b formula. We know that the cos a plus b is cos a cos b minus sin a sin b. Here a is equal to x, b is equal to iy. So, cos x cos iy minus sin x sin iy. Now, here we know that cos of iy, if you want to take this I imaginary part, we have to use the formula. Cos of I theta is equal to cos h theta. Using that formula, cos x into cos hy minus, here also sin of iy, it will become as I into sin hy. So, comparing the real and imaginary parts on both sides, we will get u is equal to cos x cos hy and v is equal to minus sin x sin hy. Partial differentiation with respect to x, we will get minus sin x, cos hy will be constant. So, we will get minus sin x into cos hy. Then dou u divided by dou y. Partial differentiation of u with respect to y is cos x will become as a constant. So, cos x will be as it is. Cos hy differentiation is sin hy. Similarly, v is equal to minus sin x sin hy. Dou v divided by dou x. Partial differentiation of v with respect to x is equal to minus side differentiation of sin x will become cos x. So, minus cos x into sin hy will be as it is because we are differentiating partially with respect to x. So, next thing is dou v divided by dou y is equal to minus sin x is as it is. Differentiation of sin hy will become cos hy. Checking the Cauchy Riemann equation. So, dou u divided by dou x is equal to dou v divided by dou y and dou u divided by dou y is equal to minus dou v divided by dou x. So, f of z is also an analytic function. Now, we will see f of z is equal to log z. We are going to check whether the log function is also satisfying the CR equations. Now, we know that log z, that is log of x plus iy is equal to 1 by 2 of log x square plus y square plus I into tan inverse of y by x. Now, we can separate the real part and imaginary part here. So, u is equal to 1 by 2 of x square plus y square and v is equal to tan inverse of y by x. Partially differentiation with respect to x, that is partial differentiation with respect to x for u is equal to x divided by x square plus y square, and the partial differentiation of u with respect to y will give you y divided by x square plus y square. Then the imaginary part, dou v divided by dou x is equal to tan inverse of y by x is 1 divided by 1 plus y by x the whole square into minus y by x square. So when we simplify this, we will get minus y divided by x square plus y square. So partial differentiation of v with respect to y is equal to x divided by x square plus y square. So when we check the CR equations, it is satisfying. Ux is equal to vy and uy is equal to minus vx. So we have checked that log function is also satisfying the CR equations. Hence, we have seen that the exponential function, the logarithmic function, trigonometric function and the algebraic functions satisfies the CR equations. Till now, we have seen the definition of analytic function, definition of a derivative function and the derivative of a Cauchy Riemann equations. Then we have seen some few examples which satisfies the analyticity. Hope you all understood the concepts clearly. Thank you very much.